Alright, well, we just finished up our first test crimp here for our little low-cost hydraulic line crimper, and as you can see, it did pretty good. Not too bad, and my specs are calling out for, and by the way, when you buy all these fittings and you buy the hose and stuff, you need to buy it from a place where you can get the specs. So the specs from the website, which was Discount Hydraulics, I believe, shows me I'm supposed to be at 20.32 for this hose with that fitting. And as we ended up, we are at about 20.54. So a little bit big, not too bad, just a little out of spec, but we hit it almost exact the first try. So let's talk a little bit about this little guy right here, because odds are when you take it out of the box, you're not going to be able to do that. And let me show you why, because there's some problems with it. As you can see, I'll put a link to this thing out on Amazon, and you can see what it looks like, read some specs up on this thing, but you'll see it doesn't have this little knurly knob thing on it right here. Well, I added that, and I'll show you here in just a second why I added that and what that does to make the little light light up. I don't know if you can see it in the screen from the angle, but the little light up in order to let you know that you're pretty close to where you need to be. It's not going to be exact. This thing doesn't work like it ought to work. It's not going to get you exact, but we also added a little gauge back here, and I'll show you how that works as well. That's how you're going to get really accurate with this little guy. So what we need to do, and then also down here, because I've never crimped any hoses before, I don't know, could be this thing might be wrong, could be me doing it wrong, but I'm going to test the hose as well with like a little hydro pack down here. So we'll get set up. We're going to crimp one, show how that's done, read through this thing, and then we're going to test it just to make sure I'm good before I go through crimping all these 27 hoses I got to do to rebuild my little Bobcat 610 and the little bucket digger. So let's get set up, show you a little bit about this button thing, and then we'll show you how to do a calibration on it, which it doesn't come calibrated. Got to do that. Then you can start crimping some hoses. Alright, so just what's up with this light right here and this little test button that lets you know that when it's crimped down all the way, the light will light up, and it's supposed to let you know you're done and you're going to be right on the measurement that you wanted. Well, that's not the case with this little guy, and they could have done a lot better on designing. But what was inside of here, if I shine the light in there, you can see here's the button to test with. There's also an identical button way back in the back, and what happens is when this thing crimps, the little blue piece that the button's on moves forward, and you can see the rod right there that's attached. When it comes out of the box, it's just a bolt. And so all you got is a bolt right here. That's why I say it's got to be calibrated, because this bolt is not in the right position, so nothing's set up on this thing. And odds are, since it comes with 8 sets of dies, the dies aren't going to be made accurate enough that you could keep the same setting for each of the dies and pull them out and make bigger and smaller hoses. So here's the problem we run into, and you'll see it's up on blocks because I had to access it underneath here to get to that right there. And you can see when I push the button, it lights up the light. The little light lights up right there. So that's all it is that tells it to trigger, is that that little plate right there moves forward as you're pumping it up, and it hits that, and it'll light the light up. So what did I do to make this thing more accurate? Well, number one, when I bought it, this thing was in the bottom. It had vibrated loose from shipping. And so the little button wouldn't light up anything because there wasn't the big bolt inside of there. So what I did, after playing with it a little bit, I decided, and let me take it apart and I'll show you, because I can calibrate it again. I'll show you what I did to make it so that when it pumps down, the little light will actually light up, and you can adjust it properly to get it to the settings, because over here is where you're supposed to set it for the different die sets as you go within the range of the die set. Alright, so just what did I do to make it so you can calibrate this little fella right here for the button, because this is the plate that's on the inside. I had to take it loose to get my part out. But what happens is when the bolt comes in there, it pushes that. So what does it look like from the factory? Well, you loosen up that set screw right there, that guy slides off, and then this whole shaft will come out. And let me show you what it looks like. And that's what it looks like from the factory if, in the case of mine, that rattled loose and fell out in shipping. But I added some little thread tape right there to make that a little bit less wiggly on its threads too. So what did I do? Because what you would have to do to calibrate it, you'd have to bring it in and out, and then this guy turns that. And so you would have to get it set to 19, example for this die set that I'm using. Then you would have to get inside of here somehow, get the cover off or whatever, adjust this so that that guy is in the right position to hit the button when you're on 19. Then you'd have it calibrated at the bottom. Then you could see, but I can tell you I played with it. If I calibrate it to 19 at the bottom, and then this die set goes from 19 millimeter to 23 millimeter, if I go to 23, it's not accurate. It's off by a half a millimeter. So it's a little bit inaccurate anyway, but it's a good idea to give you as you're getting really close, and you can recalibrate it if you're willing to do something like I did. So what did I do? Well, what I did is took this guy off, because he's worthless, and I drilled a hole all the way through. Now these are the threads that come in it. I just drilled a hole all the way through the thing, and what I did is inserted a piece of brass that I made over on the lathe that's threaded for the knurling knob, and it's got the original threads like the bolt. So slip that guy in there. Now he becomes what is the equivalent of the bolt right there. But the good thing about him is when I put it in there and I put all this together, I could put my knurling knob on, so now I can adjust this to get the position right on my scale here to here. Then I can adjust this to get the light to light up. So let's put this thing back together and I'll show you how it works here in just a second. And then I'll put my little plate back on with my button. It goes back behind that bar. Then we'll crank it down to about 19 and I'll show you how I can calibrate it so the light lights up. I'll also show you the inaccuracy of the light when we go from like 19 to 23, because here's a rod that's 19 and here's a rod that's 23. So we'll also do that real quick. Then we'll get set up and we'll do another crimp and then we'll test this guy. Alright, so with everything put back together, and I can verify my light works again with the knurling knob there, now we're going to calibrate this thing. So I'm going to see how accurate this little light is, and you're going to see that it's not that accurate, but it could get you really close. So what we got is die set number 5 in there, and if you got your little book, die set 5 does a range of 19 to 22 millimeter, and the mold number is 19. Now what does all that mean? Well, there's a little thing up here on top that tells you for die set 19, they should have put 5 there. The die set 19 is actually 5, and it'll do 19 all the way up to 23. So they're pretty close, 19 to 23 up here, 19 to 22 over there. So we're really close. We can use this one die set, especially to calibrate. So what I'm going to do is put my piece of 19 millimeter in there, and as you can see, it is 1901. We're going to put that in there, and we're going to crank down on it. Make sure your dies are all in there. And we're going to pump down on the thing. You got to open that little thing up too, or else it gets bubbles, until it locks down on it. Okay, so I'm on 19 right now. Now if I look on my gauge over there, I'm going to put a little more pressure on it because I want to be a little bit tighter. So I'm actually going to watch the pressure gauge, and I'm going to crank on it until I get a little bit of pressure. Well, that puts me right around 0 there. So I'm in pretty good shape on 0 on my gauge that I'm actually going to use. So right there is 19. So what I got to do, versus if you were using this screw in the bottom, you would have to reach up under there, take the bottom plate off. I don't think you can get it through the drawer, but maybe, and adjust this thing so that it's in the right position so the light will light up. Well, using this setup, all I got to do is set that on 00, which would be 19 on this die set. There's no adder. This is your adder. So then I just crank my knurling knob in until it lights up. And you can see right there, at that point, it's touching the little thing. So now, right there would be 19. And if I wanted to do 23, I'll show you how to adjust that. So we're calibrated on 19. So now let's just go see, because it turns off when I open it up. I'm opening the valve over here. So we opened it up. Now let's put something that is 23 in there. And you can see this is 2298. So right at 23. I'm going to put that in there. And This thing, you got to adjust it if you want the light to light up because it's set for 19. So what you would do is turn it. One turn would be 20 up here. 19, 20, 21, 22, 23. So that's 20, 21, 22, 23. So if that thing is set up right, because I got my knurly dial adjusted for 19, if that thing is that accurate, when I crank down on this, the light will light up at 23. Well, let's just see what it does. So, make sure your little thing's open. We're going to crank down on it, and we're going to watch this gauge, and I'm going to see at what point it stops moving. So right there. So that's getting close to 23. Bump, bump, bump. And I start building a little pressure on my pressure gauge. So why didn't the light light up? Well, because the button is not that accurate. But how inaccurate is it? So it didn't light up, so I'm going to go in. This would be 23, 23.1, 23.2, 23.3, 23.4, 23.5, 23.6. So the little button thing is off by 0.6 of a millimeter on the diameter. So it's not that far off, and it's actually close enough that if you calibrate it to 19 and then you go up to a bigger one, it's going to be a little bit big. It's not going to be as much. So as we can see, we're pretty close. That's pretty good. You could actually use it to get you really close, and that's what I'm going to use it for. But why did I put this gauge back here? Well, let me show you the setup on the little gauge that's going to get you really, really accurate, and you can adjust in if you're crimping and get really, really close versus this little guy that's kind of sketchy. So let's get set up over on the side over here, and I'll show you how to calibrate this thing using a little gauge. All right, so to establish a calibration curve for the die set, now you'd have to do this for each die set. I'm probably just going to use this one and maybe go up to the next die set for the bigger ones that I got to do. But I can write all this down, and then I have the calibration curve, so when I get ready to do another one, all I got to do is set my gauge up. Here's what you would do. So we're back to our 19 millimeter solid aluminum bar. And what I want to do is establish at what point I know this is 19, and I want to zero this gauge because I want to put it at the lowest setting. So I'm going to come down here and I'm going to clamp down on this bar. And by the way, I moved this out so it doesn't crush my little switch in there. So I'm just going to push it until it breaks into the second level. So it's got my thing clamped. I could actually come in here, set that up. Probably can't see the light light up, but there's the light lighting up. So we set that on about 19. Now what I want to do is zero this gauge. And so right here is the zero mark. I was pretty close anyway from where I was playing before. So we're on zero here. So what we got to write down is 19 millimeter equals 0 position on that gauge. And what we're going to figure out is how much increment this gauge moves when this thing changes its diameters. So we got 0 on 19. We set that. Our little gauge over here is on 0. So now what we want to do is put something in there that's within this die set. So we can go with a 23 because it's at the top of the die set. So let's back this thing out like that right there. Now let's stick our 23 millimeter in there. Just make sure 22.97, so pretty close to 23. And what we want to do is figure out at what position this gauge is when the diameter is 23. And so we crank her down until we hit pressure again. Right there. So at 23 millimeter, that equals something on this gauge. And so it's something is 0.1, 0.2, 0.25, 0.255, and maybe a little bit more to get the gauge about the same. So it's 0.255 inches on this gauge. So that means 19 to 23, that means we got 4 millimeters of movement equals 0.255 inches on that gauge. So 4 millimeters, 19 minus 23. So now we can figure out what the increment is between the two, and we can hit something in between. So let's crank this back off. We'll do some math real quick. what we got is for every 4 millimeters, it's going to move 0.255. Well, it should be linear because it's just a taper inside of this big old joker. And so what we're going to do is go 0.255 divided by 4. And so for every 1 millimeter of movement above 19, it's going to move 0.06375. Right? Now our spec is 20.32. So we go 20.32 minus 19. That's the difference. So we're moving 1.32 millimeter. And since 1 millimeter over on here equals 0.06375 on that gauge, we just do 1.32 times 0.06375. Boop. We got to put this gauge on 0.084 in order to make a 20.32 crimp. Now, in playing with the first one, I was off just a little bit. I was off 0.3 when I did the setup on this. So what I'm going to do, because there must be some slop in here, and this is where you would learn when you did a calibration, you'd say, okay, I did it to the calibration, but I didn't get what I wanted. I need to add 0.3 millimeter to it. So 0.3 times my 1 millimeter equals 0.06375. So 0.3 times 0.06375, that's equal to another plus 0.019 on that gauge. Because apparently there's some slop in here, and when you put the gauges on, once you hit the hard pressure, like it's going to take a lot of pressure to crimp the thing. I'm not putting a lot of pressure on these pipes. I got to add an additional amount. So that's minus the amount of slop that's in it. So it would be 0.084 minus 0.019. We got to go tighter. That's what having that slop in there would have made it go tighter. So we got to go to 0.065. So now let's crank her on in. Now we're back to the 0.1. Now we got to go all the way around. It's 50, so it'd be 50, 65. So we got to go down here to the 15 on here to make this crimp. And there we are. We're sitting on 15. Now our pressure is 3,500 psi. So that's pretty solid. And if you can see, my little light lit up too. You can see on my fingernails right there. Light lit up, and it's within that much. So it's within 0.2. Yeah, so that's pretty good. Alright, so now let's measure that. So that one gave us a tighter crimp, that's for sure. And we ended up at 0.239. And as you can see on the chart here, 20.32 plus or minus 0.13. So we could be 20.45 would be the biggest. And we hit it. So there we go. So now we know, with our math right, we can set these parameters. So anytime we want to crimp one, we just got to go set our gauge up. We can crimp it in like that. We got to remember to subtract the 0.019 and we'll be good to go. So next up, since we got this guy crimped on both ends now, is we're going to put him on our little hydro pack down here, and we're going to see if this little guy will hold some pressure. Alright, so just as a final test before I make 27 hoses and don't do them right, I can always take them over and have somebody crimp them, and we find out that it's either a problem with me or a problem with the machine. We're going to test this little guy right here we just made. So I am armed with a face shield, because I don't want to get this stuff in my eyes if it does blow, but it's fully purged of air. It's all full of fluid, so most it's going to do is just squirt if it blows. So what we want to do is try to pressure this guy up and just see what he'll do. Now the rating on the pipe says 4,785. So we can go to that, or we could go a little bit higher. But I want to see, make sure that at least it'll do about 3,000, because my little Bobcat down there runs about 2,000 psi. So here we go to try to see if this thing's going to leak or not on these fittings. And it should pump up pretty quick. And by the way, this is MPa, and so there's about 4,000 psi right there. 6,000 psi, 8,000. So 4,000, we'll try that. Here we go. There's 2,000. And we got no leaks. There's 3,000 something. There's 4,000. And I don't see any leaks. Can't see that well through my hood, but I don't see any. I see it leaking at the fitting back there. Leaking right over there, but it's not leaking at the crimp. So it's going up a little more. That's 5,000. So that's above the rating of the hose. And that's doing okay. I can see it dripping right there where that fitting is connecting, but I don't see anything on my cloth. Right here. Nothing collecting up around the crimp itself. Everything's nice and dry. It's leaking right there, right where that connects up, because there's not a very good. Alright, so let's go on up to 6. There's 6. It's still holding tight. So if that fitting wasn't leaking right there, you can actually see it dripping. If I zoom down in there, you can see it dripping on the fitting right there. Dripping on that side, but it's not dripping over here. We're not getting anything on our hose. So we're in good shape. So it looks like the little crimper machine can easily do this. I don't see any issues. So we can see nothing is wet right here. So we're in good shape. This fitting didn't leak. It's this one right down here on this junky little hydro pack that I got. There you go. There's how you crimp hydraulic hoses with a $500 or so low-cost crimper. Beats a $5,000 one if you want to go to the trouble to calibrate it and do all of that. Well, alrighty. Well, thanks for watching.